Let's start discussing access control lists. For simplicity, let's assume each user is associated with one domain and that all processes run by the user belong to such domain. In the example, we have a user A, and the user processes also belong to domain A. We define one access control list per file. As the name suggests, it is a list and it is scanned in order, stopping at the first entry that matches. If no writes are found for a given domain, then we assume such a domain as no writes associated with it. The entry can contain the usual permissions for reading, writing, and executing, but nothing prevents a system from defining more writes. An important aspect here is how we implement such a system. More concretely, what are the specific elements we store in each entry? First, we can distinguish writes for individuals and for groups. The latter are useful when we want to apply the same writes to a set of individuals that share some features, for instance, students. Then we can store writes as pairs, user ID, group ID. In this case, we refer to them as roles, since each set of writes is associated not only to a user, but also to the group such user is representing. And one user could, in principle, be associated with multiple groups. In such a case, we could also use wildcards to define writes that apply to a user independently of each group. So user ID star. An alternative implementation is to store writes on a per user, per group basis. Revoking or granting permissions is simple using access control lists. Let's say we want to change the rights associated with user A so that user A can no longer do anything with file F1. If we append to the access control list of F1 the pair A star equal known, then this will be always the first entry matched for user A, and user A will thus have no rights for file F1. Notice though, we might want to clean and keep our access control list in order to prevent it from ever growing.